Okay, this is Mr. Patterson back with the week 3 problem set for the Sigma group, the second video. So we're going to be going through problems 7 through 12 in this video. The first problem, number 7 here, it says the first term in sequence is negative 11. And then we add 4 each time. So we're talking about negative 11, then negative 7, negative 3, 1, 5, 9, 13, and 17 here. Sorry about that. There's a 13 plus 17. And when you add all those up, you get 24, which is answer choice C. Not that bad there. Number 8 says the first term is 2. And then what happens is that each even numbered term is 3 more than the first number. So this number here, 2, being an odd term, the next one is going to be 3 more than that. So we have 5. And let's just go ahead and number the terms on top. 1, 2, 3, 4, 5, 6, just to get a look at what's going on here. And then the even term is going to be the opposite of the previous term. So that's a negative 5. Even term, so it's going to be 3 more, so back to negative 2. And then odd term, so it's going to be the opposite. And then it's going to be 3 more. And then the pattern is going to continue on and on and on and on. So we notice that we have a 2 in the first term, a 2 in the fifth term. I don't know why I wrote 3 there. That should be 5. So this pattern repeats after every 4 terms. So then we're looking at, okay, well, we're talking about the 45th term. So we want to do 4 into 45 and then see what the remainder is. Because it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. as we go through. And that's going to go in 11 times with a remainder of 1. So the 45th term is going to be the same as the first term, which is 2. So our answer for 8 is D. Number 9, we were talking about now, we have this sequence, x, 13, and then 43, y, and then z. And it says each term is 4 more than 3 times the previous term. So we're looking at this number x, and we're saying, okay, 3 more than that number, 3 times that number plus 4 has to be 13. So we subtract 4 over, we divide by 3, and we get x equals 3 for the first term, which is helpful because they want to know in this problem what's x plus z. So while we don't need y for our formula, we do need to find y to figure out what z is going to be. So we can take 43, multiply it by 3, and add 4, and that's going to give us 133, and that's what y is. And then we're going to do the same thing with 133. We're going to multiply it by 3, and we're going to add 4, and that gives us what z is, which happens to be 403. And we want to know x plus z, and we have 3 and 403, so that's going to be 406, which is answer choice D. Okay. Going on to 10. In 10, we're talking about the factors of 24, which we can just list out. Any number that multiplies to make 24. Okay, that's 1, 2, 3, 4, 6, 12, and 24. And then the factors of 30. 1, 2, 3, 5, 6, 10, 15, and 30. And we're looking for the intersection, the numbers that they have in common. Well, they both start out exactly the same with the 1, 2, and the 3. And then they both have 6's in them as well. So the intersection of A intersection B, that's the symbol they use, the upside down U, is just 1, 2, 3, and 6, which is answer choice A. To 11. Okay, we're talking about 30 students signing up for a senior math class, 18 take calculus, and 22 take statistics. We want to know if everyone is taking calculus, statistics, or both, how many are taking just calculus? Well, if we look at it, there's 22 and 18. We know there has to be some overlap because when we add those together, we get 40. And since there's only 30 people signing up, that means there has to be 10 in the intersection. So 10 goes in the middle. If I label this as calculus and this is statistic, well, there's 18 total students taking calculus. We've accounted for 10, so there has to be 8 here just taking calculus. And that means since we've accounted for 10 of these statistics, that 12 are just taking statistics. But again, answering the question, how many are just taking calculus? That's B8. 12 is asking a similar question, except now we have 3 different groups. We have people taking German, we have people taking French, and we have people taking Spanish. It says no one is taking all 3, so in the intersection of all 3, we put the 0. Then it says 3 are studying German and French, so 3 goes here. And then it says 4 are studying French and Spanish, so 4 goes here. And 2 are studying German and Spanish. So we've taken care of the intersections. Now we're going to subtract those values from the totals to see what goes in the bigger portions of the circle. For instance, 25 we're studying German. Well, we've accounted for 5 with that 3 and that 2, so that leaves 20 left to study only German. 15 are studying French, we've already accounted for 7, so that's going to be 8 in just French. And 13 are studying just Spanish, we've accounted for 6, so 7 are all studying only Spanish. But in this case, we don't have the other written rule where everyone is studying at least one language. In fact, that's what the question is asking, how many are not studying a language at all. So we have to figure out how many are inside the circles to then figure out how many are going to be outside the circle, because it's 80 total. So we've accounted for, if you add up all those numbers, 44 total people. And that's only a portion of the 80 that we're totally talking about here, leaving 36 to be part of what's called the universal set, meaning everybody else who's not in the circles. So the answer is 36, which is answer choice E here. Hope you guys worked well through these problem sets. If you're struggling, please send me a message, and good luck on the week 3 assessment.